Okay, bench, that should work. So, in the last stream, which was pretty long actually, seven and a half hours, we, and now this is bugged too, come on. I have to restart again. Let me restart. Okay, we are back. So, you see my USB setup. So in the last stream I had plenty of issues. One of the issues was my USB hub, which kept resetting. I know why this was. This was because it didn't have enough. It didn't have enough USB power. Somehow the power supply for it just died, and instead of having 5 volts from my power supply, I just got the 5 volts from my computer, and they dropped to 4 volts. So the USB devices on it just kept restarting. That was the main issue. This is fixed. I still have, the USB is still not super stable, but it is stable enough. You've seen that in the beginning of the stream I had to restart OBS because the USB capture card has an issue, but it should be better. The other issue I had was with the wiggling camera. This camera was mounted on this table here, and as soon as I moved the table, it would move the whole camera. Now if I move the table, it just moves the table and the camera doesn't spring so much. So you will still see some wiggling, but a lot less than with having this camera on an arm. That's fixed. Also, I'm changing a bit the audio setup. I don't know why, but there is almost 2 hours of stream where there's no audio. Although I didn't touch anything, at some point it worked again, I have no idea. Now I'm using yet another device to record my audio. This time this is a lavalier microphone, a wireless again. And let's see if it works. So the sound quality might not be as good because I don't have the microphone right under my mouth, but I have it right under my neck, or on my neck under my chin. But for now it seems to be okay. And this is actually the device I was using for recording the audio, and I still use it a lot. I like this device. I use it for my podcast, and I use it for recording plenty of other events and things like that. This is a Zoom H4n. It's a very old audio recorder. I think it's not even sold anymore. It has black and white screen, but I still like it a lot. It records really well in quality. You have here a built-in microphone where you can set for 80 and 120 degrees. Here you can put an external microphone. This is where I used to put an external lavalier microphone if I had to interview guests. And most importantly, you have 2 XLR connectors. I think they make other. They surely make other devices. The other big brand is Tascam, I think. Probably all the same. And you see it is old because it's using USB Mini B instead of Micro B. So it is quite old. It is not supported anymore. What I hate on this device is the boot time. Let me show you. This is the boot time. So there's the animation. This is quite fine. What takes forever is this now loading. And what it does is it reads from the SD card, and this SD card is empty. Still, if it's empty or not, it doesn't make a difference. It will take like 1 minute to load. This is a huge, but it will take a lot of time. Although the SD card is completely finished, but that's the main downside. Else I quite like it. It's portable. You see the age also, not only from this connector, but you see the age because here it uses NEMH battery, so AA batteries. And now you would have LiPo all the time. And I want to switch this system from AA batteries because I constantly have to open this trap to remove the batteries. You cannot charge them in place. So I constantly have to open the trap to remove the batteries, put them in the charger, put them back. It's a bit annoying. And as you can see on this piece, the plastic is getting broken. This plastic is still living, but it is now getting bent. This part is completely off. And on this side, it is also getting broken. And I have issues. This is a tripod mount, so it's not on the ground. There's kind of a rubber feet where it stands. And having this hole, I don't know who designed it, but having the hole, let me remove, having the tripod mount right under the battery is really a pain. Or here, having this quarter inch, I think, screw mount right where the battery is really a pain, because removing the battery cover is always a hassle. This is probably also why I broke this tab, not because also because I opened and removed it a lot, but also because it's hard to remove it. So I want to have a solution. What I plan to do is putting a rechargeable LiPo batteries inside here, so I don't have this hassle of charging the batteries externally. Although I love system with these rechargeable batteries, but here it's getting annoying because of this trapdoor. Not a very good design. For that. What you can also see here on the battery compartment is the stamina mode. This is where it kind of reduces all the functionalities or limits all the functionalities, but this way the batteries hold a very long time. I think just with these two batteries I can hold 2 or 3 hours, something like that. I wouldn't dare more. With this on, you can easily hold 5 hours or more stamina mode. I don't use it very often, but when it happens, it's quite useful. So having this low power reducing is a nice feature. I think also this is not meant for rechargeable batteries. It's meant for normal batteries. I don't know. But I'm using rechargeable batteries because it chews a lot of energy. And you have here, what you can see here, a 5-volt input with 1 amp. So you can actually power it with USB power banks. So you don't use the batteries on the inside, but then you need the cable, you need the external USB power bank. This is not the standard, is it? Let me check. 5mm, it doesn't look like a 5.5mm plug. No, it's not. It's kind of another plug. I think I have the cable somewhere, but yeah. So the task today will be to replace this battery with lithium polymer batteries, with a lithium polymer battery, which with an included charger. So let me get my box of batteries. That's my box with all my batteries, and I'm sure we will find a fitting battery here. What we need to do is first open it and see if it works correctly, because these are two AA cells. So when you have them in rechargeable, it's a nominal of 1.2 volts. If you have them as alkaline, it's 1.5 volts. So it means that the input shouldn't exceed a lot more than 3 volts. But the lithium polymer batteries are nominal voltage of 3.7 volts. So I have to check first if, why are you not working? I have to check first if this can operate with 3 volts, 3.7 volts, if it has a voltage regulator, a boost or something like that. Else what I need to do is have the battery boosted and connected to this 5 volts internally. So let's take it apart and let's have a look inside it. I think I've taken it once apart, but I didn't have to take it very often apart because it works. It works really well. It's a bit harder to see. And yeah, you can also see that it is getting old because I'm always removing the SD card to dump it, because through this interface it is pretty slow. It works, but it is pretty slow. And I don't always have a USB mini B cable. Micro is standard, mini has been getting phased out. Although I love micro, it's a lot more robust, and I prefer mini over micro, but it's getting phased out. And you see, one of this plastic tab is now getting apart, so it is getting old. Let's opening nevertheless. And what I also don't like, what you see here, this kind of rubber which is on the side, this doesn't age well. It gets gooey after plenty of years. So here I removed the rubber with, I think it was either alcohol, acetone or something like that carefully, and then I painted it in black again. And it starts to get on this side too. So this overmolded, I removed most of this overmolded, I don't know, rubbery material, which doesn't age really well. But it is an old device. I've started with it. It was, this one is not too expensive. It's the entry level, and I'm very happy with it. I didn't have to change it. Compared to the microphone, I have plenty of different microphones, and yet today we are using yet another microphone. So the screws should be under the feet. Yes, they are. Wow, this is pretty. Oops. This screwdriver is not long enough. Okay, not very repair friendly. Often you have a screwdriver with bits. If you do, well, you can't open this one. So let's use a longer screwdriver. They're too tiny. I will here get a box where to put my screws so I don't lose them because they're very tiny. Well, very tiny. I've seen smaller embedded devices, but they're not too large. So let's have a look at it. And I'm not afraid of breaking the warranty. I think there's even no warranty anymore. It's not supported. The software hasn't been, the firmware hasn't been updated. There's no. I got a couple of bugs on it, but really not a lot. I think at my 5+ years of usage, I've got, oh, this is not the same screw, this is central. I've got probably 3 bugs occurring, so it's pretty good. Is this screw here? Did I remove it? 1, 2, 3, 4. Okay, 1, 2, 3, 4. So it should be removed. Let me get this badger. So now the camera is not mounted on my table anymore. I don't have a super good view on it. I can't see immediately if something is off camera view or not. So you'll have to bear with it. Okay, do I have to remove this also? Not very useful. Maybe I do have to remove this. I hope this modification doesn't take more than 1.5 hours, something like that. So no, this didn't help. So this was not what's in the way. What is in the way? I don't have any. It was just, oops, I hear a click. Generally these are the buttons or the switches. Yes, this is the stamina switch from the back. I still can't open it correctly apart. What is holding you back? Did I read? No, there's no screw here. And here, neither here. So, okay. Not sure if it's completely. Oh, I broke something. This tiny bit of plastic. It's not for the menu, so it probably was holding something. Where did I break? I don't see where I broke, where this comes from. I think it was holding cables down. Yeah, there are marks. I think I've added the marks. I don't remember. On the cables this way, I know which one is which one. And okay, one is the stamina, one is the sound recorder. Cables, this, yeah. And the connectors are not the same, so I can't switch them. So what did I break? This is the speakerphone. Not very good, but enough to verify if the audio works and to listen to the output. Else you just connect the headphone, and with the headphone you can listen to what you're recording. So I don't see any missing part or broken part here. Where does this come from? This was actually, okay, this is the part which was broken, which was previously here. So it was still inside the device. Maybe need to. This was here in the device. So yeah, this is the broken plastic from the card reader protection. So we have, oh, how does it work? No, the stamina button. Okay, this connector is for the battery, not for the stamina button. So here we have the battery. Here we have the battery input, And this looks like here there is using a tiny bit because of the angle. Can I change the angle of the camera? This clear. This is a tiny bit better. Let's see if it holds. It doesn't hold too well. Up this way. It will fall a bit down. It's not an issue. Up. Okay, so you have this glare. Yeah, so this is the battery input, and we can see it goes in here. And this seems to be a booster instead of a voltage dropout voltage regulator, because there is a coil here. So I don't know if it boosts up or boosts down, but it changes that. What we could also do is just connect on the leads here the voltage power supply and check if it still works with 3.7 to 4.2 volts. But so the input has capacitors, electrolytic capacitors up to 3.6 volts. No, 6.3 volts, so we can feed in, and the output is 4 volts. So is it a buck boost? Now let me check if it's the output or the input. Let's get the multimeter and go to. This is the input. Yep, this is the input. So the output is probably working at 3 volts. I don't know. What kind of connector is it? It's a tiny, I don't know what it's called, connector. Seen it multiple times. Maybe I have one of these so I can play with it. So here, let's have a look at my connectors box, where I have plenty of different cables inside. Screwdriver go here. Batteries, I don't need you right now. Do I have one of this? I don't want to use this one because the cover is getting these because I use them very often. The other ones are just salvage, so you have plenty of form factors. And this looks like this fits, and this is the right format. See, salvaging is worth it. So, what is plus, what is minus? The minus is the one with the marked cable. Oh yeah, both of them are marked. This is minus. Okay, it's in the up here. This part's. So power supply. These three things, I put them in boxes too. Let's put them in this box. Up. This goes here, this goes here. We're at 3.8 volts. We will lower it. So this is minus. Minus is connected. Oh, now it's a bit too zoomed and you see nothing what I'm doing. So here, power supply, and you should see on the dashboard, you should see actually the value if the software did not hang. No, it seems okay. It says it is connected. So the software seems fine, but it's still hanging after some hours. I have no idea why. The batteries we don't need anymore. Let's provide 3 volts and let's see what's on the output. So voltage 3 volts. Let's limit to 500 milliamps. Let's test how much it draws. 3. It draws nothing when it is off, which is very good. So quiescent currents, no. Okay, but 500 is not enough. It just hit the limit. Let's give 1 amp. Okay, it needs a lot in the beginning, and when it boots, it needs 150 milliamp. Are you seeing it? Yes, you're seeing it. So 180, 150. That works correctly. And normally, if I switch the voltage, the current should change also if it's a switch mode regulator and not a linear regulator, because it just doesn't burn energy. So let's first measure what's the output to know what's the operating voltage. Just out of curiosity, we don't really need it, but I want to know, right? Because I'm curious. 3.3 volts. So this is a booster. Oh, that's not good. Can it... What happens? So yeah, it's kind of... Yeah, this is a booster simply... Yep, this is a booster because from the 2 volts it boosts up to 3.3 volts. And this is why the cap is only 4 volts per output capacitor, although it needs 3.3 volts. Normally I check like double the voltage. I use capacitors with a rating double the voltage. They are hard on the limit. But yeah, they use 3.3 volts. Let's figure out what happens if I provide 3.4 volts. Is it buck boost or is it just boost regulator? Let's try it out. So voltage, we had 3 volts. 3.1, 3.2, 3.3. Oh, the output voltage, it's still 3.25, so it's a buck boost regulator. That's a good thing, but it is unexpected. 3.4, now we're at 3.3 volt input. Okay, no, it's not. Now I have 3.5 volt at inputs and the multimeter is 3.4 volts. So this is a boost voltage regulator, which takes this output. So we cannot connect directly a battery to this part. Now, what about the 5 volts? So this is the connector. Here we have 5 volt input. Does it use a low voltage dropout? Because then I can connect it here instead of connecting it here. And normally with the 5 volts, I should also be able to operate this device even if there's no battery. But I don't remember if this is really the case. I should check it. Okay, first we have to open this. Here I have to remove the screws. I soon have to, oops, these 2 screws are not the same length. I should have marked it that these 2 screws are not the same length. And actually I should put it back because we don't need to open it. So these are the 2 screws. Which one is the short, which one is the long? I think this one is the short. Yeah, it feels like the short is already grabbing. Yeah, this one is the long, so that's correct. This is the one in the middle. This is the countersunk. Let me mark the screws. I forget, there will be even more screws. Up, 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 up. Up. Pen. Back case corners. Back case or lids, not sure how to call this part. And this is middle, center. Okay. Let's test if this battery operates. Do I need to find this cable? I'm not even sure if I have the cable, but what I do have is a box with plenty of barrel jacks, plenty of different forms. So maybe I have one which fits. That will be a tiny bit faster. This one doesn't fit. This one doesn't fit. This one probably doesn't. It's not. The center is not large enough. This one, the center is also not large enough. See, plenty of cables, but none. This one might work. No, doesn't. This one doesn't. Do I have none of them? This one might. Still not. The center is not large enough. The internal diameter. This one also doesn't work. That's for laptops. That's for all laptops. This one will not fit. The internal diameter is not good. This one also doesn't fit. Do I have to? I probably have it. Just in my case for this recorder if it's inside there. Yes, it is. I should have looked here. So this is the cable I've created, and you see I've just connected USB to it, and then I have this connector which is also spare, and I have a pretty long cable so I can have the USB hub, the USB power bank far away. For now we will try to find out if this works. So, let's switch the power. Battery. Let's connect USB to my USB power bank. And this will get connected here. Yes, it fits. Can I switch it on without battery power? Yes, I can. And it shows 100 milliamps. So, and we will have a look. So I probably have to give the input here. What if here I don't provide 5 volts? Maybe I just have to provide something above 3.6 volts, but do I have to test it out. So a cable from a USB cable here. USB cable with some leads, and this way I can provide the voltage I want to it. Tack, tack. Let's remove the leads from here. Plus, minus, let's set it to 5 volts for now, 1 amp. And did it break again? Yes, I have somehow to periodically restart this device to kill the software, underlying software. And now I switch on. Okay, it operates. Let's try to have it booted. 180 milliamps. So yeah, any battery, any lithium polymer battery should be enough for that. Now loading, and let's see if the volt. Okay. So this is also not good. Can it switch on? Did it say that the voltage, external voltage is? I didn't look at it. Did it say that the external voltage is not okay? Let's try it again. So this is on. Okay, now let's go down with the volts. Ups, volts. 49, 48, 47, 46, 45, 44, 43. Or you see the LCD dims, but it doesn't warn that the external power supply has issues. And for 2 it switches off. And for 2 is the maximum voltage which goes in. So we cannot also use this connector. Okay, this is starting to getting a bit more complicated and won't be a small project, but let's have a look at it. Maybe I will have to cheat. This one, yeah. I hope these two screws are others. No, they're not the same. Who makes screws not the same because of this asymmetry of this device? It's not helping. So this was left, this was right. Left, right. Oh, what I also have instead of that, what I could use, now it's too late. It's just, here. This device. This magnetic part, and then I should have a pen with it here. Internal mic, left, right. And since it's a tiny bit magnetic, when I put the screws on it, it should hold left. And yeah, it's not moving too much, and right. So I'll use this. Now, can I remove this part? Okay. I want to have a look at the inside of this device. I'm sure new devices also have a lithium polymer battery. Okay. Seems to be more at stake than just that. Can I actually... Oh, this is just the power supply board. Ah, it is. This is just taking care of the power supply and the whole other board, and they have different colors. And this is why... Okay, this is power coming out. So here there's a... Okay, on this XLR connectors, you can also power the microphone. And this is called phantom power because it is a differential signal. You can put higher DC bias, the DC offset. This is how you can provide power to the microphones. And this is why we have power coming here. And this is the voltage booster to switch it to 20, I think you can set 24 or 48 volts. This is the cable we see running here up to there. Switch, zoom a bit more. So this is only taking care of the power supply, but not for this thing. I still want to see the other parts. How does this part open? Ah, do you have to pry it? Oh, it's not. Okay. How is it holding together? Do I really have to dismount this thing? What is holding you back? Ah, There are two screws here. Didn't see them. Probably you saw them. From the top, they're easy to see. These two screws. I've opened this device once. I don't remember it being it's so complicated. But yeah. This has somehow been hacked together. It's really not ideal. So, come out, screw. Don't want to come out. I want to grab you, but I have nothing to grab you. No, uh-oh. I need to hold. Come on, screw. If I can't. Oh, okay. Here. These are the screw. We call them. Let's put the two screws here. Now it opens. Here we have this record button. This is the front. Then we have the LCD, which I'm sure I'll make a mess out of it. And there will be marks. Let's get. So this is the inputs. Now I want. Okay, we can disconnect the microphone. Wow, it's super heavy. This is probably made out of metal. And yeah, these are good quality microphones. I do plenty of concert recordings with these microphones and I'm happy with it. On more, I've seen, I think, a Zoom H8 or something like that, a model with 4 XLR input, which has even more amazing microphones. But for now, this seems to be sufficient. So this connection, what is this? This is the input power for the voltage booster. Why is it coming? Why is it not using? Here we have plenty of connectors. Okay, here we have the USB. 3 board construction. That must be expensive. Well, this device is also not very cheap electronic, so I think they take it back in, but here they cover a chip, I don't know why. So this is the microphone. Oh, microphone, the XLR inputs. What is this? This, okay, this is coming this way. This is to power the board, okay. This is probably the output to power the main board, and the main board uses a 07F 0536A. I don't know what this microcontroller is. It is doing the LCD part, so this seems to be the digital part. For the menus, you have also the SD cards. No, it's here. Here we have an Alcor AU6254. This is doing the USB. Here we have a very tight compact TSM, so this is probably Here we have, there's internal flash, or what is this? Under this, this construction is weird. Under the SD card reader, we have a tsub package. Tsub is normally used for flash, so it might have some small internal flash, or maybe it's to some buffer before it writes on the card in case the card is too slow. Good question. Here we have plenty of audio devices, analog audio devices. This, I wonder what voltage it provides here. That's probably the 3.3 volt output. We will check it. I don't know. What is this? Okay. This is probably for the this capacitor seems to be here 4 volts. This capacitor might be for the RTC, so it keeps the date. But on my device, if I don't have the battery for 10 seconds, then it loses the date. I have no idea. So we see for the 2 volts. Now we can connect this again, and we have to put 3 volts on it. 3 volts. What is plus, what is minus? I already forgot. This is minus. This is plus. Zero quiescent power. That's good. This is good because then, okay, we'll come to this solution later. First I want to check. So there should be a side switch, I think it's this one, to enable the device. Yes, is it booting? No, it's not booting. At least the screen doesn't show it's booting. Because I disconnected these two parts, so it cannot start the screen. But it can still provide the voltage here, which we can read. What does it need? It needs nothing. It doesn't output any power. So this is probably the power to be for the voltage. So for the voltage booster. Let's try to connect it. Microphone, you go away. Let's switch it off before I connect it. Which way was it? Where's the connector? There is, no, this is a microphone connector. This is the connector. It went this way. Right, yes. This board-to-cord connector, quite expensive and flimsy. Let's try again. Now if I switch on, the LCD screen should switch on. Yes, it does. So that works. Now we can try to measure the... now it's hidden. But it's the same as here. So let's try to measure the voltage here. On this, so here there's 0 volts, but it's okay because it probably only provides volts when I select... I do have an output on 1 and 2. And I think they are, here you see 48 volts. So I do provide 48 volts on this XLR connector. And maybe now there is a voltage coming here. No. So I don't know what this is used for. I have no idea. I don't know what this is used for. Yeah. This is weird. And it's thick wire. Can it be powered back? Maybe because this is not connected, it doesn't provide the voltage output. Let's try it out. So let's put this module on. Okay, this is on. This is in. Let's switch it on. Yeah, there will be plenty of things. I will have to clean the screen. Now loading. Okay, 48 volts. Should be 48 volts. So now here we should have something like 48 volts. Yeah, 46 volts, good enough. Do we have something here? No, we have nothing. So I don't know what this is used for. Is it AC? No, I have no idea what this is used for. But let's not dwell on it. Let's switch off, and now I want to see how the power is regulated from here. So we can disconnect this again and get it out of the way so I don't lose it. Let's have a look at this board. So that's the input voltage. There are no components on the front where the tactile buttons are, so they should be somewhere on the back. Somewhere on the back. What does look like a voltage regulator? Probably something like this. Let's go. Because there's a diode. Diodes are because huge diode, and diodes are generally used for power. No. Here. What is? Well, this is center. This should be plus. Is there a MOSFET somewhere? Plenty of test points. Does it feed back? Do the 5 volts feed back here? So does it put 3 volts here? Let's try it out. Let's connect to the 5 volts and up. Switch on. Is the switch on here? I think. Yes, now it draws energy. Let's measure the voltage and see if here there's still 3 volts. This is ground. No. So it has 2 power paths. It is on, right? Oop. The screen doesn't work still. But it draws, it draws no power anymore. This is not very useful to debug when you have to always have these things plugged together. Because I cannot analyze the parts which are on it and I cannot make measurements. Yeah, not debug friendly, not at all. Let's switch it on. It doesn't switch on. Let's switch it on. Now it switches on. Loading. No card. Yes. At least it starts fast now. There is no card. Now that there's no card. So this is on. On the battery we see no voltage. Let's see if we see voltage here. Between here and here. 3 volts. Okay. What I could do is tap on here the 3.3 volts and just put a voltage regulator, an additional one, a low dropout voltage regulator, which can provide 200 maybe more than 200 milliamps. To have some would provide more than 300 milliamps. I will have to look at my parts list. I think that will be the solution because the voltage regulator on here, I still don't know which part it is, but is not capable of working under for the 2 volts. So I have no idea why, and I don't want to change it. And here it's a boost converter, so I will have to connect a 3.3 volt voltage regulator here. Does it work if I connect? So here we have plus, we have minus. We can just tap on the output capacitor. Let's switch. Yeah. Let me check what voltage regulators I have. So let me have a look at my SMD book. I do have others also. Do I have some in tubes? Let me check in my inventory. So in my inventory, let's And I'm sure you won't also have to have a quick look at my inventory. Let's do it here. For my inventory, I use Part Keeper. It is not, I don't think it's maintained anymore, but it still works okay. And it's the only self-hosted solution I know of. There are plenty of others, but I want to be self-hosted. I don't want to rely on external service for something as crucial as your inventory. And an Excel sheet doesn't do it anymore for me. So, voltage regulator. We could actually use, no, we won't use a step-down converter because the quiescent current is just far too high. We will use LDO. On LDO, what do I have? 3 volts, 300 milliamps. This would be something nice. 300 milliamps and something good. Here. AMS module. I forgot about these ones. And they are small. You see the picture on the right? No, you don't, because there's something on the front. I'll show you afterwards. We have adjustable. We have these parts, but these are only 50 milliamps, something like that. Yeah, this is not enough. 200 milliamps? No, it's not enough. We've seen that it uses a bit more. It uses 200 milliamps with a booster. So probably, yeah, 200 milliamps. Too hard on the limit. I won't use it. Voltage regulator. I do have my box here. So these are not the SMD. I have to switch the camera. Let me switch my camera to bench again. Here, this is my box of non-SMD voltage regulators, and I think here is the part I was looking for. And this might be a good solution. This part here, which is an AMS 1117. So just look for 1117. There are plenty of voltage regulators, and normally they can carry a lot of current. So this might be a bit big. They won't be capable of handling so much current. So I might use exactly this part. I still have 3 of them. I have plenty of voltage booster modules, which is good because this voltage booster you connect batteries to it and you have 5 volts all the time. There's no intelligence. It doesn't ask you to have a minimum current draw, which I hate on power banks, that the current draw is something like 35 to 70 milliamps, because when I just put a small LED on it, well, it switches off the LED because it doesn't draw enough energy. It's just meant for charging. So I like these modules, and I use them for my power banks. So yeah, we will use this module here for 3.3 volts. And 3.3 volts, we don't want the LED though. We will remove the LED because the quiescent current on this is probably high enough. Let's check it. Let's check it out. So we should have voltage in and ground. And we will put, so let's switch this off. We will put, oh, this is not good. We will try to see what is the quiescent current with LED. Current will be a lot lower. Which is fine. There will be quiescent current on my LiPo battery. I don't mind because I will have a battery protection. So this The second part. Up here on my battery management box, I will use a battery charger, something like this, but instead of having micro USB, although it would be nice to have micro USB, can I put micro USB on the case somewhere? This way I don't need mini USB to charge it. That could be something good, or USB-C, I don't care which one of them, but that would be a nice feature. Don't want to put it on this part, I wanted to put it somewhere here. This is not meant for it. Maybe if I put it inside somewhere next to this, where is it? This plate, there's this plate. Here, I could put it next to the second one, just below it, and have the micro USB for charging. USB-C is too large. Probably I don't have enough space. Let me check. This USB-C, you see, it's twice as high. And micro USB for charging is still the default. So let me see if I can put this here. Should have plenty of space to put this here. Yeah. I'll make a hole on the side which will allow me to charge with micro USB. I will still connect, and this way I don't have to tap on the 5 volts on the input lines here to charge it. I really charge separately. What I thought in the beginning is I would use the 5 volt from this connector to charge my battery, but now I don't need anymore. I will just use this. And this module has, because it's a bit larger, this is no, it's not a TP, but it's a 4056. So generally it's TP 4056. This is a lithium polymer charger. And then we have here battery protection. So they don't allow drawing more than 3 amps, which is, we don't need this anymore. The most important is they protect against over voltage and under voltage. That's the most important part. And this tab, or the V-score on this, is really bad. The V-score on this is so bad that they broke the PCB and gave me the PCB with the V-score holder. Wow. Okay, this is done. The problem will also be I won't see if it charges or not, if it is finished charging or not. So yeah, I will put this way, tuck, and hold it with some warm hot glue. I will just have to pay attention that it doesn't create any short on the bottom. So I will somehow cover this with probably just tape. This way I can put it here. And I didn't see that happening. Oh no, is it fine? It's probably, yeah, I will probably have to put it here, in here. That seems like a nice solution, doesn't it? And then it just connects to the battery, but I still want to be able to put batteries if I want on it, so I'll have a second connector. I'll probably have some leads going through here where I can plug my lithium polymer battery on it. And is it high enough? This is where the battery goes. Do I have enough space? And that's a good question. No, I don't. Okay, so it sandwiches really on top of it. Okay, so I don't have the space to put this. Could put it inside, but then I don't have access to it anymore. Okay, so it's not as easy as I thought. There's not a lot of space in this device. What I could do is have it somewhere like this. No, There's no space here. Ah, oh, there's space nowhere. Damn it. So I will probably have to tap. It seems like I'll have to tap on this USB, and I will have to charge it with mini USB because I don't have the space to put the micro USB device. And this is the stamina button right there. These are the cables. Yep. Oh, there's even not. This is fun. Whoop, 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 whoop. Here you see there's a footprint for an electrolytic capacitor, but it is in the way of this box, and this is why they're not populating it. So, yep, the one which did the electronics or the board design didn't know about the case previously, and the case has been just given out afterwards. But well, also it's looked like hacked together. Today you would have something on one board. Here you have 3 boards. It's huge, really expensive. 3 boards design. Well, no, not very manufacturer friendly. So we can't put this thing here, so we will probably have to put it here. We'll have the battery next to it. I can remove this micro USB, so we save some space. Then I put the battery here, and then I need some cable, and I can even, where is it? Here, this board. I can just put it next to it. This way it gets directly the battery output voltage, which we can feed in here for having the 3.3 volts. And then the 3.3 volts can go through here, through one of these connectors to the board directly here. We will tap on this. We will tap on this output capacitor. This is where we will inject the 3.3 volts. And we need some wires from the 5 volts here. So I will have to charge it with mini USB, but that's okay. Could also switch this. So do I have somewhere the traces for the 5 volts? Let's take this apart. Let's take this apart. Come on. Here we have the 5 volts. Do we? Whoa. Ah, they're going hidden somewhere, probably through this fuse. Let's measure out. It would be ideal if I would have the 5 volt pins somewhere on this side so I can solder on it instead of having wires, although I could have it is going this way. I could have wires going along here, but it would be better if they are on this way. So let's check continuity. Do I have the 5 volts somewhere? Which is 5 volts? I think this is ground, meaning this is 5 volts. And here we see the 2 USB for the micro. 5 volts. No 5 volt pad. Very weird. Where are you routing the 5 volts? Are you going through a diode? I see the diode. Damn it, I need your 5 volts to charge my battery. Through a diode it's also okay, but I need to find where you're going. The problem is that the track on the PCBs goes under the connector. So, do I have to reverse that? Where is it going else? Ooh, they even have different ground planes. This ground plane is different to this one, and they're coupled using a capacitor. This is something I know nothing about, how to do it correctly, or if it is really required. This is some audio specialties. Okay, so the track is going behind here, so it should land somewhere. Here. Oh, seriously? This is a 4-layer board? Probably it is. Here we have a via. This is the via where the 5V are coming out of, but you see no track on this side. And if you have a via with no track on one side, it means that, well, there's a reason to place a via. You have to cross between layers. If there's no track on this side, it means there's a track inside here. So this is a 4-layer board. This is just audio. Come on, how many layers do you need to do audio processing? This is proof. And particularly because this is an old device, 4 layers now is very common and not very expensive. At the time would be really expensive. No wonder it costs so much. I wonder if this is also a 4-layer board. Check if it's this way. So it is getting internally routed somewhere. I don't know why. Yeah, this is 5V. This is internally routed. I can still tap on this via. Poof. Poof. It's not beautiful to tap on vias, but yeah, but it's doable. Maybe I will really have to have a wire coming here and then along here. It's probably better than having it here because I don't want to break the via. The via is a lot more fragile than this pad. I probably have cables going to the pad. If I tug too much on the via, then you have no internal routing for the via. Probably it's solid enough, but yeah, no risk. I don't need a risk. I should have enough space for routing without the via. So this is one side. Well, it's a bit more complicated project than I expected. And I will need some foam. So here there will be a cable. We need 3 connections. The ground is probably the same everywhere. Is it? Is the ground of the USB the same as the ground on the charger? And I can't test it because they are all disconnected. So let me connect it back and let's test if I need only one ground or if I need more than one ground. This goes here. Doesn't it? Yes, I think this goes here. We've seen there are several grounds. Maybe the power ground is the same. Hope so. So this, okay, the shield is not connected to the ground. Yep, the ground are the same. So I don't have to tap the ground. Actually, so I just have 5V, 3.3 volts and ground. I can tap ground here, 3.3 volt and 5V. There will be a small wire coming from the bottom. Let's do it this way. How much space do I have? How tight does it fit in the case? Where is the front case? This this is the front. So there will be more space. Do I need a really tiny wire like AVG 40 or will AVG 30 be good enough? So this comes here, we don't need U anymore. This is then connected here. So there will be at least three voltage regulators. So this is connected here. This is connected here. Yeah, I have enough space for an AVG 30 cable. Yeah, that's good. I should have enough space. Oh, there's the button. The button should be inside here. Does it matter? No. The orientation doesn't seem to matter, but it doesn't fit correctly. Okay, we need to desolder this part. We need to solder it here on the output. Check. And this is compact. No, now it's not ideal, but normally it's good because it's compact, because you have some parts on one side, the other part on the other side. Here it will just take a bit more space. So what? Desoldering gun getting heat up. Now we can start soldering things. Also the soldering iron. Here's the soldering iron. Bit of water on the sponge to clean the tip. This is somehow ideal. I could even flange this on top of this thing. Yep. Yep, I will flange this on top of this thing. They could, if they do this, they could even use thinner PCB. Now batteries. I didn't check which battery can fit and will fit. I'll take the largest I can. Oh, and I have to test. No, normally it should be fine. There's this one. It is a bit, I'd like to have a bit larger. This is too large, this is too large. What I also have, what could be useful, is these. No, that I can't. These are AA form, but this is LiPo. These are LiPo batteries in AA form. This one, which is 400 milliamps, it's not a lot. These batteries, how much do they have? These batteries, they're AA cells. There are two of them. They are in series. 1900 milliamp. That's a lot. 1000 milliamp would be nice to have. 400. I could have two of them. Doesn't look nice. Oh, this battery. Damn it. It would have been nice. Just a tiny bit too large. This battery. 1200 milliamps. Oh yes, this battery. I think this will be the solution. Yeah, I will use this battery. 1200 milliamps. And yep, Now this will be less because we're losing a low dropout, but I think it will be enough. I will have to check on the recording with stamina if it holds enough. But this seems to be like a good solution. And then we need to fit, can I fit the board inside of having, instead of having to put it here? That would be even better, because I think I have not enough space to have the battery and the board in here. Let's check. No. Can I put the board somewhere inside? Yeah, not enough space to put both of them. Yeah, just barely enough for this one. Is it high enough? No, that's not high enough. I will have to find space in the case. That's a challenging task because it is really crammed in here. No, it is this way. There is space here where this one, where this part normally fits, but it fits the other way around. No space. Okay, I know where I could fit it. I would fit it, it would be nice if I could fit it on the correct side being where the USB is, so I don't have to run the wire super far away. But I also have an idea where I could put it. So this goes here. Yes, it is super crammed. Yeah, I'll have to cheat. Yeah, I have to. So there will be a 4-layer sandwich, although this is a tiny bit separate. There will be a 4-layer sandwich. And this, I can put it on the back here. And only because I want a large enough battery. If I have a smaller or more flat, if this would be flat, then I could put my battery inside. I have something which is a tiny bit more flat. I have this, but this is just 400 milliamps. It's not enough. I have these. These are probably 200 milliamps, 100 milliamps. These are very small. Even if I have two of them, no, this is the ideal one. No, yep. Don't have any other batteries which would fit better than this one. This is the right one. I have to cut the cable to put the connector. Oh no, this one, sorry. This is the right one. 400 is just too small. Because they are too high. And I'll probably put directly this next to here, so we know that it is for the voltage input, because I don't have enough space on this thing. Do I have enough space? If I fit this here, this goes here. Do I have small? Maybe this MOSFET switches on off the power. So yeah, I'll probably have to tap here. Let's check if the 3.3 volts are going to a pin directly. So let's unsolder this using the desoldering gun because it's making a lot of rackets. I don't want it to be on longer than I need to. So let's hold this and let's remove the solder on these pins. Come on. It's hot. Okay. Let's wait a tiny bit. And this should come off. Yes, it does. Okay. Pin is gone. Let's switch this off. Let's noise. Why does it need to be so noisy? There is a fan running all the time, but to cool what in the inside unit? I mean, the heating element is in the gun. I should have a look at that. Yeah, if I could, I would connect it directly like this, but I don't have enough space. This, yeah, I don't have enough space. So I have to put it on the side and then have some small wires. That's fine. And here there's a tab, but it's not touching anything. So yeah, I could glue it inside. Let me get the glue gun and heat it up. But first I want to find out, is the 3.3 volts on this board going directly from here without. So, and I can't test it because there is a board on top of it. That's the 3.3 volt output. Does it go on one of these capacitors? No. And this, let's check on these capacitors. That's plus. No, it seems to be switched. So I cannot connect the 3 volts on the button below, on the board below. I have to connect the 3 volts here. And I can't test if this is, oh, I can. Let's test if it is. No, it's not, not on one side of the pins. And I can't test the other side. Here. Don't go directly. Yep. Actually, what I didn't test is, does it work if I just provide connected to ground and 3.3 volts, and we will test it. Let's have some wires. Do I have something better suited? No, I have to solder wires, there's no connector. Up. Let's prepare some wires with my AVGC silicon cables. Up. Up. 2. Let's tin the leads. Solder. My lead solder. Then I need to shorten the leads because it's too long. Lead free. Screws are in there. So I need to put a tiny bit of lead on the contacts, else it doesn't solder well, and then it will put a bit of flux also. Okay, so plus will go this way. You're not seeing what I'm soldering. Let me move the camera a tiny bit. This way. And now you have the full glare of the overhead lighting. No, this way. The ground, actually I could put it from anywhere, but let's take it from here. Okay, the ground pad, the ground copper layer is huge and doesn't warm up enough. Okay, that looks nice. Let's keep it long enough so I don't have to cut it twice. That should be done for now. 1, 2, and let's see if we can power everything with 3.3 volts or if it requires more. This is connected here. All the boards are connected, and now 3.3 volts, 1 amp. This is minus. This is plus. So 3.3 volts. Doesn't draw anything for now. If I switch it on, yeah, it seems to work. Okay, getting scratches on my screen now. Not good. Yep, I'm putting scratches on it. Damn it. Can I clean it? Oh, did it switch off now? Did I switch it off? What happened? Low battery, goodbye. Oh no, come on. You're measuring the battery voltage? And if you don't find any battery voltage, you're switching off? Do I have to cheat? And do I have to provide you a fake battery voltage so you're just happy with the battery voltage? Or do I really have to put 5 volts? Okay, so at least it's good that I tested it now. Let's try to see if I can clean the screen. Yeah, it switches off. So this solution doesn't work. It needs 3 to 3 volts, but it wants a battery voltage. And if I give you too much battery voltage, okay, so no for now. So yeah, I did add some scratches on the screen. It's still usable. It's not large enough. Yes, large enough. I have to provide using the 5-volt port because I won't have a battery connected to it. Let's keep the screen from getting scratched even more. So let's switch. It's 3. Well, it's 3.2 volts, sorry. 3.3 volts, I think it does make a difference. It did measure the battery voltage, but let's try it again with 3.3 volts. 3.3 volts, low battery, goodbye. Damn it. Damn it. So, I really need to tap on this 5-volt here so it doesn't monitor the battery voltage. Because there will be no battery voltage. I could create, how is it called? A voltage divider using resistors, but this would waste even more energy. Okay, so I have to find out how this works because you can power the thing here. So let's find out where this goes. I didn't think about that. I didn't think about the battery voltage. Testing is good, but at least we did it now. We won't be surprised afterwards. And all the time I'm spending here are probably not worth it, and buying a new device would work, but I like this device and I like twiddling around and reversing devices, so let's continue on that path. So why do I have 3 pins? There's a center pin, there's a bottom pin, and there's maybe a contact to figure out if everything is connected, but are they connected together? No, yes they are. And this is the center pin. This is the main voltage. What? It goes through a capacitor? Why would you have a capacitor on both sides? That I don't get. There's no charge. Yeah. Let's unconnect this. Yes, I have no idea. Why do you connect a plus on both sides of a capacitor? This is super strange. Okay, you're going here, you're going here, you're going here, you're going here. This is the power trace. This is the plus, right? Let's try again. Yes, this is the plus. So once you are here, I don't want to feed 5 volts directly, because the problem if I feed 5 volts directly, well, I have to. If I feed 5 volts directly, I need a constant booster, voltage booster. And these voltage boosters use energy. For example, let's take from the quiescent energies higher. Let's take this voltage booster here. I don't need to solve anymore. For example, I was speaking about this voltage booster which bursts up to 5 volts, don't know how many milliamps. And if I connect it to 3.3 volts, just 1 milliamp, it's a lot more efficient than I expected it to be. Maybe I will use this part instead. Let's check the 5 volts outputs. Yes. Let's check it out. 1 milliamp is really not a lot. It's still some energy, but LED. Let's just remove the resistor to the LED. The resistor is 1K. And I will leave it on the board, but just on the other side of the pad. This way. See, I've disconnected the resistor to the LED. Up. Disconnected the resistor to the LED right here, but I still have it on one. So let's switch it on. 0 milliamp. Could use this. And we still have 5 volts. Yeah. Let's try if I can power it using that. That might be the simpler solution. Again. This was here. This was here. This was here. Here I have the voltage booster. And if I connect it to this 5 volts, now this 5 volt cable, does it still measure? No, you don't see my power supply. Stupid. Okay, I need to reprogram the software. Up, I'll do it off screen. Now you see it again. You see it draws 0 milliamps. If I now switch this on, then it draws amp. But at least, and what is useful is that although this is not 100% efficient, it is probably more efficient than an LDO, which just burns energy. So this might be more efficient. And then I don't know if they use an LDO, so maybe it's not efficient, because if here they use an LDO, then this is not efficient anymore. So 300 milliamps, we have 1400 on this battery, and means that it would 1200. That's this one. Yeah, it would mean it's ideally it would work for, and it's not recording, for 4 hours. With recording, it's probably only 2 hours. Yeah, 2 hours is not bad. 1 hour is good enough, else I'll just plug a USB on it. But yeah, that might be the solution I will use. I will use this board. So, and not the 3.3 volt board. Yeah, 300 milliamps, and I'm not sure how efficient this is, but it's a good solution. I'll have to just try recording concerts every week, so which holds something like 1 hour. If this holds 1 hour, I'm happy with it. And loading. Okay, no car, I'm fine with it. Ah, it doesn't show any battery power. Does it use the battery? That would be interesting. That would be quite nice if I can still put battery and it doesn't use the battery. Yeah, this is on top of it, so I could still use this and have batteries as backup. But it means that if I still want batteries as backup, I have to fit my battery inside here and not inside here, because this would only be the backup. But I don't want it to be the backup. Yeah, I will fit the battery here, it's too large. I could fit a small battery maybe inside here. Not that big. Here, but we've seen that we have no space in this device. It is crammed, completely crammed. Yeah, we have no maybe I have space here, but this is there. No, we have no space. No, the battery will need to be on the back. This is how I'll do it. So now I have to find out, this I will remove, and I will actually cut the board here. So I save some board space. And this is the output, and we have ground. Can I put it on the side? So this goes in here. Everything is so crammed. I wanted to put the board here, but it won't fit. I'm still surprised this can fit. Yeah, this fits this way. Ah, it fits. Well, this is not complete correctly in. Let's put it correctly inside. Okay. These cables are in the way. These cables out of the way. No, super crammed. I'll need to find a space where I can fit this. Oh, and it says super high capacitor. This is probably also too. Maybe no, I can't. Okay, it fits here. This hole fits here. What if I cut? What if I cut? No, it's not fitting. I wanted to cut a part of this side to fit this here, but no, it won't work. Oh, this way maybe? Could be. But I don't want to have. No, it should be fine. There's also another switch mode. Power supply. Maybe I can fit it in here. I'm not sure. No, this is maybe not a switch mode. No, 4 volts, so it might be a switch mode power supply. Maybe I can fit it in here. Yeah. No, no. Nope. The board doesn't fit. I think this is holding it here, and is it? Oh no, okay, that's the spacer. Can you fit in here? Come on. Fit in? No, you don't fit in. Why does it have to be so complicated? Do I have one where the part is already cut? The smaller one. This one, tiny bit older. Ah, it's not much smaller. No, it's not smaller. No, I don't have any. Or is the parts cut? Nope, I don't. So, can I fit? No. And maybe it is a bit. It's not as high. It's still too high. It doesn't fit in here in height. No idea where I have to put there. Where I can put it. This is getting complex. Well, this is getting complicated. Complex. So, where can I find some space where I can fit it in? Here there will be the battery management, battery protection. So I need some other, maybe on the other side, where this cable is going. Yes, maybe. Let's open it. Let's check it. So on one side will be the battery management. This probably needs to be on this side. Yeah, this fits here. On this side, could I fit this here? This way. Something like here. There's some high components. Okay. Can I close it with it? No, the stupid connector is on the way. Is in the way. And what if? Let's cut it. Let's get my metal clips. These parts, and then let's cut the board. Okay, I thought it was easier. Do I have to desolder first and then cut it? I think so. Well, let's desolder the part. Let's switch on the desoldering gun. At least I gain a connector, even if I don't need them. I have to look what I have to change the fan in here. That will be my next mod. Let's finish this mod first. Does this have still some juice, or is this battery dead before I do anything? .9 volts. It is good. Okay, so this is now put in. Yeah, this has enough. I have enough space for the battery connector, but I need to remove, although I need to clip the leads here because they're too high. Clip, clip, clip. Okay, now it doesn't short. Soldering gun is warm. So let's add some solder so we can move it better. Yep, works. Sometimes to desolder you need to solder. And now most of the clips are fine. Up. Do I want to salvage it? Yeah, maybe first. In the risk, let's salvage it. So this is the connector. We can, oh, the ground is only connected with this tiny pin. Let's keep these connections, but let's at least cut all of that. And this way I can solder cables on it. So, save some space. Desoldering gun. Clean. Oof, this is too noisy. So, does it fit here? Can I fit it in here somehow? No. This is too high. Can I fit it on ah, maybe I can fit it on top here. Fit. Even with the speaker, is the speaker high? Ooh. No, it probably will make clock with the speaker. So we can remove also these cables. We know that I can't just provide 3.3 volts here. Up. Yeah, if I could put it here, it would be nice. Let's check it out. This connector we also don't need anymore. I want to fit this tiny board. It's not so big. Too large. The output capacitor, do we need it? Yes, we need it. This output capacitor, else won't be. Oh, here it might fit. Might fit here. What is? Oh, there's a microphone. If I put it this way, oh, it looks somehow to fit this way. And the microphone. Yeah. I have to run wires everywhere. Did it go this way? Yeah. Can you fit here? With this board connected, it goes a tiny bit higher, but maybe it still works. Let's try it out. Yeah. Yeah, it's, does it fit? Does it fit? It seems to fit. Yeah. Yeah, there's a tiny bit of space, so it does fit. Well, we found our place. It will be here. I'm afraid I will make shorts, but I don't know. But it will be here. Plus minus, that's the input of the battery, and I need to put it this. Oh, can we slide it more inside? Oh, it's fine. I don't want to slide it more. It does fit here, so let's keep it this way. Yeah, right here. Does this still fit then? Oh, seriously? No, it doesn't. Ah, wrong way around. Must go this way. Yeah, it fits. Up. On the border, right there. Put some tape so we don't make shorts. Up with the bottom, then we can still solder cables on it. Scissors. And cutter. Cutting table, cutter. Maybe, yeah, the solution would be, does probably exist, but it's not very efficient. There might be some 2 times AAA batteries, AA batteries with USB inputs which charge them, but then you have because you have 2 batteries, you have 2 circuits. Maybe it exists in dual pack, I don't know. So it needs to go this way. Now it doesn't short. Let's get the glue gun. Let's start building things together. Then we can put all the cables where they need to go. It's a project which is the most crammed I've seen until now. This is one side. Let's do the same for the other. Let's keep this charger just to debug. Let's keep this charger, this part. But let's also add some tape on the bottom so it doesn't make any shorts. Up, up. I'll need you soon. Okay, device is ready. And I still didn't decide how I will connect this. Where's the battery? Where is the battery? It should be somewhere. It's not the battery. These are charging pieces. Let's put them in battery management again. Up. Battery management here. This voltage regulator, I don't need it anymore. Let's put it in voltage regulators. Good. So, this connector, we can put it on the side. This charger, I don't need you. This was too clean, that's gone. I don't need the cutter anymore. Here's the battery, and I didn't decide on a connector. I want to use a connector. Do I have, I will just use one of these cables probably. Will go in the battery. And this still needs to fit here, inside here, will it? Which way around? Does it matter? Yes, it does. Here there's a plastic. Leads on the connector. Do I want them smaller? No. This way I can reuse the battery, although I won't. Probably won't. Get some shrink tube. Yep. Oh, I can use color shrink tube now also. Too large. Let's use some color shrink tube, red and black. Black, red. Far too large. Black, red. So what is the polarity? I can still switch it, but I'm too lazy. So let's put, you're not seeing what I'm doing. So this is red, this is red. That's a good solder part. This is black. This is black. Oh. Shrink tube 1, shrink tube 2. Hot air gun. Okay, that works. And now the cable should go in here. Connector somewhere there. Ideally you would use a smaller connector, but this seems to fit. But you need to stay on top. Hop, hop. Can I close this? Here's the cover. Not perfectly, it's not flat. Oh, the clip. It should be flat though. Maybe I just, the wires were in the way. Yeah, it's not very flat. I don't know why it's not flat. Who pushes it? Pushes it, but then we have the leads here. Too much of a drama. It's not, but it should be able to be flat. If I press here, it really should be able to be. Ah, there's this bump. I didn't put into this bump into account. But it's good enough. Okay, now we have plus minus volts, plus minus the voltage. So glue gun, tiny bit glue, not too much. I just want to hold it together. Somewhere around here. Does it close? No, it's this way. You move this way. Okay. Here is a directly here. Up. 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 Okay, so I need to use my file, save some space. And now if I move the table because of this, yeah, the camera doesn't move too much. That's good. What is this output? Where does this output go? Oh, there's no output here. Okay, so I can. Cut this off, and I need to cut the plus off. Is the plus connecting something? Yes, so I can't completely cut it off. But I can cut more off. And I need to protect this capacitors. I don't know if this is on plus or minus. We'll just protect it this way. I don't care, and I don't have to measure. Having some tape is not a drama. Up. Up. Okay, this way there's no short. Let's try to place it again. Try to check where it belongs to. This shouldn't make shorts. Oh, maybe it does. I don't want this board to stick too much out. But I can't more than that. Can I still put this on? It sticks a tiny bit out. No. Okay. This is the output. This is plus. And this is probably not minus, but the minus should be a bit everywhere. So see here. Yeah. Let's get it more. Up. This is cuts. Up. Now it fits and hides. I need to cover this. I don't know if ferrite is conductive. Is it? Oh, let me check the resistance of ferrite. Ferrite or this part. No, it's not conductive. Oh, that's good. Check again. No, it's not conductive. So we will put it this way now. And this way it seems to fit. Yeah. 2 millimeter off. Okay. Probably the minus is still connected to the minus. Let's check out. Is the minus common to this one. Yeah, okay. So I can have just one minus. I don't need the two of them. And now it doesn't fit, although I removed. Yeah, now it fits. Now it fits nicely. Let's try again. Glue. Tiny bit of glue. Up. Board. Yep, this fits. So we have this at least. Now I have no idea how we'll put the wires all along. But we will do that later with the wires. For now, let's add the second module. This is also protected. We wanted to add it here. And it does fit in here. So let's add some glue. This is the connector of the battery. It's got the leads a tiny bit. And let's try if everything works out. Yeah, let's connect one after the other. Let's try first with the battery. This is the input, so yeah, we can have the wires running. So battery plus up. Battery plus, that's done. Battery minus, let's already add the solder. So we just need to add the cable. Yeah, this way around. Okay. So now on output plus minus, we should have 3.6 volts. For the 2 volts because the battery is connected. And we didn't trip the parts. 4 volts. So this works, and now we need to connect the 4 volt output up to here. For that we can use these wires. Can we connect the ground? The ground here could be connected to already the ground of on here. But we still need to connect the ground here also. Plus, so we'll have two ways where the ground is connected. So this is, we'll have the first ground here. This is the ground. Is this ground? This is not ground, is it? Yeah, we still need to connect ground here. Let's see if there's something. Let's have a tiny bit of more wire in case there's something in the way. Up. I think it's not a good idea to have it live, so let's disconnect the battery. Up. This is sticky. I want to remove this sticker from the battery. It's getting in the way. It is really sticky. Let's disconnect the battery first. Disconnected. Let's remove this sticky thing. but the smell is strong. At least the sticker is removed cleanly. And I used some, I don't know, it's an anti-sticker spray, something like this, just to remove stickers, and it's good for the glues, which is often used on stickers. Any anti-sticker spray should work. Okay, so let's continue our operation. Minus. My fingers are sticky. I'll wash my fingers. So let's add some solder. I still did decide where I want to connect the ground. Let's first add this. And then we can add plus. We should use other wire, but now I have plenty of red wire, so let's use the red wire. This is too long, and I still need to tin it. So let's first tin it and then make it shorter. Up, up, up. Tinned. And shorter. Okay, that's plus. Plus goes around here. That's the output. Have some solder on the cable and on the lead. And let's solder it on. Now we should have, no, we don't have 5-volt output because it is not connected. Okay, that's done. Now there are two cables more I need. I need the 5 volts to come from the 5 volts from the USB to come to the battery charger. I need the minus, which is here. I'll just connect the minus to this board. Probably all the minuses are connected. So if I touch the minus here and here, we should have some. We don't. This is minus 2, isn't it? There are several grounds. Well, there are several grounds, but seriously? Even on the capacitors, there's several different grounds on the capacitors. So I cannot directly connect ground to ground. Maybe I just didn't touch the right pin. This is ground. Oops, sorry. No, it's not the same ground. No. 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 Is this USB ground? Is the DC plus ground different? Or is another ground pad? Let's connect this. Oh, let's see if it fits. If it fits, then I can continue. That's completely in. So, is this ground not the same as this ground? It's this ground. Okay, this is the same ground. I can't test, I think. Where's USB ground? USB ground, it's this one. I It seems to be this one, but it's not. Ah, here's the 5 volt. That's ideal. Okay, I'll take the 5 volt from here. Okay, and this is the ground. This is the same ground. Is this ground the same as this one? No. So this is a separate ground. This is the microphone ground. Or microphone jack ground. But this ground is the same as this ground. I need another ground somewhere. This ground here. I want... No, it is the same. Why didn't it work? Seriously. Did I mistouch the ground? No. Okay, it's not this. Can't be that I... The USB ground is not the same as this USB ground. Where does USB ground go? USB ground is this thing here. This, is it this? Which one is USB ground? Okay, this was just the USB ground, which is here. Okay. And let's put this back together. So we have, this is USB ground. And this is USB plus. Oh yeah, I'll just tap USB ground and plus. And wait, this connects somewhere here. And where is this ground here? This is ground probably. Okay, is this the ground? Yes, this is the ground, but it's a different ground than this one. Come on. Why don't you make my life easy? Huh? How should I now have two different grounds? You're really not making my life easy. I could have the USB charging works now and the output, but the problem is that they all have the same ground here. It's the battery ground, which is also used for the charging, so it means I would bridge this ground. I would bridge the ground from the USB, from this input. Okay, this is this ground. This is the ground. Okay. Where are you going? You are going here, here. I don't know what it does. I don't know what happens if I short these two grounds. For now they are not shorted. But I need to short them. But, well, my circuits will short them. They probably have a good reason why they don't short this ground. But we've tested that this ground is the same as this ground, right? Okay, this ground is the same as the power ground, but it's not the same than the USB ground. Ah, okay, they are the same. They are already shorted. It's just that it needs this power board to short them, to short all grounds together. Ah, okay. So it's just shorting all the grounds together, right? Yep. This power board shorts the ground together, shorts the grounds together. So that makes it a bit easier. So I just need a ground wire. Plus and minus, we have it from USB, we have it here, so we'll tap it from there, although this ground is the same as this one, so I'll tap it from here, right? Yep. Let's do that. So we have ground here, which is the USB input ground. We'll connect the ground, this ground there. Oop, oop, oop. I went too fast. I didn't let the solder cool. And we will connect it to this ground, which is right below. Yep. This is a huge ground plane. Let's heat it up before. Yep, it is a huge ground plane. Solder directly the ground across the capacitor. Okay, we have ground soldered. And the plus should be here. Where is plus? Plus. Plus. And one ground is enough and the cable is good. There is a stray whisker though. No, not a stray. How is it called when you're not? Or is it stray? When you're not where you should be. Okay, that's done. Here. Plus, and let me prepare the plus on this via. And because the via is untented, we have access to it. Okay. I think nowadays it's not very usual to have untented vias. Previously, it made the process harder to have tented vias. Now it's rather standard to have tented vias. And plus. But you can still choose to have untented vias. Just adjust the solder mask. Come on, plus solder on this via. Okay, plus is soldered on the via. So normally, if I connect a USB mini, let me have a USB mini cable. Let's not use this switch. Let's have a power bank. Power bank. Now if I connect USB mini, this should light up and tell me there's no battery connected. This does light up and you see blue means that the LED is charged, but when it blinks red, probably hard to see on the camera, but this blinks red, flashes red. It tries to charge all the time the battery. So this works. So here we should also have output. We don't have the LED because it's not always on. The ground should be connected. So now we just need to connect the plus to this thing. Here is plus. And then we should be fine. Oh, this is too short. Let's have a thicker plus. Okay. The plus is on the output of the diode because this is a boost converter. I don't know if the difference of what boost and step up difference is. Are all step up boost converters? Are all boost converters step up? I don't really know. This is the output. Oh, I need to add some solder on the output. I think all step up are all boost converters are step up, but there are other kind of step up converters. Okay, that's the plus output. And we can try to route it below here. Although if there's this notch, it probably means there's a reason for it. And we can route it as a place for putting the cable all across. Stuck again. Now I need to this way. So let's see if it fits somewhere around here. Let's add a bit of slack. And we can connect it to the plus here. We could connect it also to the plus on the bottom. Do we want to? No, we'll add the plus here. Yeah, it's less. Although here, this thing I don't know. This is where this connects. So yeah, in the middle there's space. Let's see. Yeah, in the middle there's enough space for the cable. So let's solder the cable on the plus here. I'm sure it goes also somewhere on the board. I could connect it on the board somewhere. Where was it? Let's probe it out. We're still in continuity. Where is minus? Yeah. This is plus, right? It goes here. Then we've seen that it goes all the way up. Does it go somewhere on this board? No. It is not across the board. So this is plus. It goes here, here, here. All along here. Up to somewhere here. This is the plus. Not here. Here. Damn it. Is it? This is the USB input. The thing where I didn't know what it is. This is the USB input. We have plus and we have minus. This is the USB input. That makes it a tiny bit easier. Now at least I know what it is. So we can really tap on there. So the USB output should we can have it go down just right here. Could also have the minus connected there. Do we want the minus connected there? No, we have the minus connection right here. One minus connection should be enough. So plus you can be shorter, can be something like this. I still want to be able to connect the 5 volts externally with plug if I need to. There's plenty of solder here already. Let's just add. Okay, having the 2 cables connected will not be super easy. That's the first one. Let's tin the seconds and let's try to connect the seconds also on this plus. Okay, plus is also connected. Now we can try the complete board if it boots up. with the battery. Before we do it with the battery, I would like to do it with the power supply with constant current to protect against shorts and just simulate the battery. So we will use leads, and I'm sure that the program, oh no, the program still works, so you can still see the output. Up, that's plus, and minus is here, minus, plus 3.3 volts. No, it will be 3.7 volts. Ah, wrong one. Plus, minus, here is minus, plus, and now if I nothing, it draws 0 milliamps. That's weird. We have 5 volt output. So any ground. This is ground. This is voltage output. No, it is oscillating though. So is it trying to have 5 volt output, but it's not able to? Up. This is ground. This is plus. Okay, we don't have voltage coming in. Battery out. There's nothing. Battery in. Okay, battery in, there's something. Battery out, there's nothing. Means that the circuit had an issue. Let's connect the USB to reset it. Oh, it doesn't detect the battery. No, wait, it does detect the battery. Okay, now the output should be fine. Now we should have 5 volts. That's 3.7. Here we should have 5 volt output. We have 5 volt output. Now we connect the board. I should monitor the outputs. This where we should see 170. We should see 5 volts on this cable, on this thing. Here you connect here. This way you are on. And if I connect you here, I should read 5 volts. Yeah, there's 5 volt output. And it uses 170 milliamp, but it doesn't switch on. And it doesn't switch off also. Okay, what the hell is happening? This thing should be able to provide enough current. I didn't test. I should have tested if this tiny board is able to provide enough output current for this device to start, because it shows a lot in the beginning. Well, it says 1 amp on the USB. Okay. works directly. So, battery management, voltage regulator. Should it have worked? Let's try one of these voltage regulators. And instead of connecting to the... Come on, I have to break it. Oh, this grooving is a pain. Okay. Whew. That was hard. So let's disconnect the battery. Let's connect directly to the... Here is in... Oh, it was the USB, but you can't... Now if I switch it on, is it able to switch the screen on? Okay. Is this device not able to output enough power? Let's try with... Should be longer cable. Yeah, the cable is long enough. Let's see. Which is quite new. Here. This is able to charge, to protect, and to provide 5 volts output, and I have 2 different ones. One with a USB connector. This one, I think this is the better one. Yeah, this is the better one. But I want the smaller one. And actually I could have everything on there. This would be small enough. And this is able to have minimum... that's the issue. No, it's fine. This, if you don't draw less than 80 milliamps, it switches off. So this is good. But can you switch it on afterwards again without having to reconnect? Or do you need to push the button all the time to start it? That's a good question. That's the problem. But this doesn't work. This is not able to provide enough power. I should have tested it beforehand. Let's try again. Yeah. Start. Is it maybe because... if this doesn't work, we will disconnect. Did I connect the ground? Yeah, here. Let's disconnect plus first. Okay. Does it work now? at all. Ah, again, because this board is missing. Plus, that shouldn't make a difference because there's no USB. Let's try to disconnect the plus here. Okay, let's switch on. Switch on, still doesn't boot. This is getting depressing. Did I forget a connection? No, this is the speaker, this is this. Disconnecting. Tweezers. Now no cables are connected at all. The modules are still there, but no cables are connected. Let's try again. Oh, I need to connect this. Up. Okay, this is removed. Let's remove all our modules. Okay, this is removed. I don't know what my modules did, but now it boots. This would be nice though, but yeah, this is the issue that it switches off. And we need a way to reset it. So, this module is powerful enough. So I don't know, but this would be nice because this has already management. Test this module again. problem is, yeah, it switches off, but can I switch it on afterwards? That's the does it detect when something is plugged in? Up 5 volts. And here we have some ground. Yeah, we have 5-volt output. Normally, if it doesn't draw anything, I connect somehow. That's 5 volts. Let me connect ground. Are you still able to see? Oh, there was a huge spike, but yeah, you see the measurements. 5 volts, yeah. There's 5 volts. And now, so I switch off after, 30 seconds. After 30 seconds, it should switch off. And let's see if after 30 seconds, it switches off. I can switch this thing on. Because it still outputs tiny bit of voltage, probably to detect that there is a sudden current draw. No. No, if I switch on, it doesn't detect. Oh, it does. Now I switch it on, it outputs 5 volts. And now if I switch it on again, oh, this might be a better solution because it is more compact than this thing. Well, we have wasted, well, we did waste this module because I can still keep it and it's a small form factor. But this seems okay. So let's switch off. Goodbye. We'll try again. If it works, I think I have to switch on 2 times. One time for the module to switch on and one time for the, how is it called? The sound. So for the module to switch on to have 5.5 volts and then another time for the sound recorder. So let's switch off. Okay, now it's 1 volt. Ah, you also see it here. Well, it here. Here, 1 volt. And how much does it draw? It draws nothing. Okay, that's 1 volt. Now let's try to switch on here on the USB control on this device. It did work last time. You have to detect the current draw. How did it work last time and it doesn't? Did I touch something by accident? Everything's connected. Switch on, please. Okay, this module doesn't want to switch back on. Maybe it needs more for power draw. It did work once. What did I do differently? If I disconnect this, still 1 volt. Now I connect this. No, it still doesn't work. What did I do differently for it to work? I want that I switch. If I want to switch this on, I want this to switch on without having to press on the button. I could move the button, but it's really not ideal. This should, when I start, this should draw something. If I disconnect, probably if I disconnect the capacitor's discharge and if I reconnect, then it is detected again. No. The ground is not. No, the ground is connected. It's okay, it's the same ground. The ground is the wrong ground. Oops. Now I just create a mini short. Damn it. Okay, this is the correct ground. And this is plus. But you also see it on my screen. Here, 5.1, you see it here and you see it on the multimeter. Okay, that's 5 volts. Normally, if I switch on, this should work. It doesn't. Why is this not starting again? Because it's 1 volt. Let's start it. Up, 5 volts. Now I should be able to switch this on. Okay, this works. And it is very efficient. 120 milliamps. 200 milliamps, no card. If I switch off, 200 milliamp, that's okay. If it draws 200 milliamp, meaning it doesn't switch off automatically. Okay, this is off. Now this should, the battery manager and charger should switch off. And now I want to be able to switch it back on. Let's wait 30 seconds. Maybe this chip has issues with detecting. And we see it goes to 0.9 volts. I don't know why 0.9. But yes, I'm not able to switch it back on. Maybe it needs, when it's completely disconnected, does it go higher? Okay, that's completely disconnected. Charge it slowly, but really slowly. Oh, come on. Why did it work once? Maybe I created a short. Make the device wake up. I have another one. Maybe the other one has better detection. Let's try it out. It's this one. So this is battery plus, this is battery minus. Let's try it out. Up. Battery minus, battery plus. Up. Up. 5 volts. I should switch off after some time. How late is it? Come on, the stream is 3 hours long. This should be a 1.5 hour hack. They should switch off also after 30. Ah, okay, now I get it. It needs 5 volt to create a draw because there's kind of a protection inside. This is why it doesn't work. So this circuit doesn't work. So we really have to use this one. And we have almost all connections. We just don't know why it doesn't work. And we've seen that we have space for it. So this circuit would have been better because it's smaller, but we always have to press on the button. It doesn't have a standby 5 volt all the time. That would be ideal to have standby 9 volt, standby, how is it called? Standby 5 volts, but the chips, yeah, are too intelligent. They're meant for power banks. Yeah, this doesn't work. So we will not use this chip. Neither of them. This is actually, if you're looking for this board, I liked it because it's a module all in all. This is using the IP5306. This is the better quality one. 5 volt boost. This handles 3 amp. It cuts off at 3 volts the battery. So this is the battery protection, and you require at least 45 milliamps for it to stay on. Else after 30 seconds, it goes down. This is kind of a knockoff, or it has the same footprint. I don't know if it was before or not. And this is using the FM5324G. Same principle, but this one is only capable to output minimum it's 2.8 volts, minimum is 80 milliamp, and I didn't write it. Oh, I didn't write it. But I think this is only capable of 2 amps or 1.5 amp. This is capable of a tiny bit less. Okay, it doesn't work, but we've seen that it should work with this circuit. So let's try it again with this circuit. Let's try it again. This is plus, this is minus. We have 5 volts, and with the 5, sure, it will draw 1 milliamp all the time. I'm fine with it, with 1 milliamp. I always charge the battery before I go on a mission. And it has there is battery protection. So I'm fine with that. So let's try it again and try to find out why it didn't work, why it didn't boot. First let's connect, can I connect this? Yeah, let's try it again. Hup. How can I try piece after piece? Let's try to connect, let's put this board on. Here nothing should make a short, no, nothing makes a short. Let's put this board on. Let's connect it to the 5 volts. This board. Here, should be somewhere around here. Let's try out. Okay, this fits. Oh, no, I have to put it on the side, else the capacitor doesn't have enough space. Damn it. Now it's too warm. I have to put it on the side. So, to remove hot glue, just use alcohol white 30 seconds, and then it removes. Well, it wasn't 30 seconds, but you got the idea. Not sure why it works, but it does. Let's clean off. Let's add some glue again, and let's put it on the right side. Okay, glue. Somewhere here. Does it fit? Does it fit this way around? Yes, now it fits. That's the right side. So let's try to connect the plus again. Do I still have the wire or do I have to make it again? I have enough of this plus. New again. The helping hand is here. Let's tin it. Yeah. And this which is here also to the USB. This way we have both of those things connected. Tweezers. Let's connect the minus and let's see if it works. I shouldn't be watered, but I don't want to test now. Let's get a thing. Where are the two pins? There should be two pins somewhere. Here's plus. Here. Oh, let's put this somewhere safe. There's two. And where's minus? Here. Minus. Okay. If I switch on, we should have this. We should also see the 5-volt outputs here. But I need to connect all the boards. Well, not all, but most of them This is connected. This would also be connected. You can crammed. This is connected. The battery. Okay, we should have 5 volts. We have 5 volts. So we should be able to switch volts because of that. We should have 5 volts, so it's probably not. Did it switch this off? Okay, now it is connected correctly. Let me check with the multimeter if we have 5 volt output here. One lead, where is the negative lead of the multimeter? Or positive lead? Here. Do we have has gone in protection mode? Let's reset. I need micro USB. Should have the micro USB somewhere here. Okay. Okay. Now we have 5 volt output. Disconnect. That's more than the other one, so it is less efficient. The other one was using 200 milliamps. That's a huge difference. This, where is it? This circuit was using 200 milliamps. This is using 300 milliamps. It is less efficient. But 300 milliamps means, yeah, we should hold long enough, but this works. Now, let's connect, switch this off. Let's connect the battery. Hot glue. Before I connect any Let's go here. Micro USB. Oops. Ah, we can't switch on because of that. This is missing. This is connecting the grounds. Up. Now we should be able to switch it off, on. Now it switches on. Okay. Now I just have to connect the micro USB. I can leave this on. I don't want to touch it anymore. I just have to connect this plus to the USB plus so it charges. Yes, switch on works. Now we will test with the battery. Come on, switch off. Now we'll test with the battery instead of the power source, as we want a real life test. And I just need to find the battery. Here. Battery, battery. Here we don't have 5-volt output. First, so let's connect the mini USB. The mini USB should indicate that this is charging. Yes, it is charging. And we have voltage output. We have kind of 4.6, now 5, don't know why, but this is charged. Last part, putting in the case, is probably the hardest part, because it's so tight. Up. So let's the button is correctly there, so let's put this thing in. Okay. Okay, let's put the side covers. Oh, they're holding the board. Side cover, second side cover is here. Yep. This is going there. Okay, that still closes. And now we need to put the microphone. Exactly, we need the microphone. I hate these FPC connectors. Such a pain. I get a spatula here. This is getting frustrating. This is important. I recorded. Then don't close now. Should I do it before put all together? Okay, I'm kind of holding it open now. Okay, it's in. Okay, it is in. Now these two screws, correct? Does it go? Yeah, this way. And these two screws. Right and okay, hidden holder. There's no right and left on this one. Screwdriver. Magnetic enough. Yes. One, I didn't tighten it up yet. I just want to place the other one. I think it's not in the right place. No, it's not. It's completely not in the right place. This screw is on the way now. Okay, you two go a bit back. Now I should screw the screws in. One, two. Okay. I just need the last board, this board. I don't, yeah, I can power it. Not an issue. Up. This is wiggling. Let's see if it... this should be held by this one. And this... Okay, this is held in place. This is not wiggling anymore. There is somewhere the button. This button, which I just thought I put it in the case. It shouldn't be too far away. Here. This button here. Okay. Let's try it out with the battery before we close it. We can put the battery inside. That's okay. Battery connected. We have to reset again the circuit because we've added a new battery, and the board needs to know charging state of the battery. Up, up, cover. Cover. It's on it. This is stamina, this is spring. We don't need for now. I want to connect this though. Okay, this is connected correctly. This is for afterwards. This board is tightly in there. Internal microphone, right, left. Yeah, I think we need to put these before we can close. Yeah, we do. Screwdriver, screwdriver, here. This is right. Up. I think we don't need the glue gun anymore. Let's switch it off. This is left. Okay. And now we should be able, we need to charge it once. Well, charge it connected to the charger. Yeah, this red LED is on, meaning it charges, it is charging. And now we should be able to switch it on. And it works. I didn't clean the screen. Well, it's readable. I could open it again to clean the screen. Let's try if it works with, is this microphone? Yeah, no card, okay. And see, now I will connect the card. This is an empty card. See how long it takes. Now loading, and it is empty. And this is why it is taking super long. This is frustrating. Okay, close this. I don't know what it does. I have no idea. Yeah, I want to open it and clean the screen. And there's a really dust particle which is annoying. Still loading. Okay, now if I press on rec, we should have some data here, so it works. So let's switch off. Is it enough to just unscrew, because I didn't screw a lot, is it enough to just unscrew these screws? Let's test it out. Okay, they're unscrewed. I should remove this, and now can I remove this complete? Are there other screws? These screws are not holding anything. I don't remember having put other screws. And these are, no, these don't seem to hold anything together. So this should lift out. Ah, they're just tabs. Where is my tab opener? Here, this part. Okay, yep, they were. These are just tabs. One, tab on the other side. Two, this is almost a complete construct. Up. Ah, now the button fell off. Up. That's one screw. Let's put it in hidden screws. This is the other one. The button also fell off. Now I can clean both sides of the screen. Up. Let's just use some window cleaner on both sides. No, maybe too much window cleaner. No, it's okay, it's evaporating quite well. Let's use microfiber tissue. Remove the dust, particles. That seems right there, some scratches. I think, yeah, the scratches were there before. Well, before. I made them previously, I don't think. Yeah, I'm thinking this I can remove. Let's try with some rubbing alcohol. Yeah, here we've seen that there is a side to this connector, this side. Yeah, so let's try with some alcohol. Up. Okay, this looks nice. Here too. Screen looks nice. And now we can put, now I touched the screen. Now we can put everything back together. Oh, let's disconnect this, you're in the way. Screen, board, two sides, which are holding the board together. Really complicated assembly, this thing. One, and where's the other side? Should not be too far away. Here. Here's the other side. One, two. Okay. Microphone. 1, 2, 1, 2. So screws to the microphone. Okay. Oh, the cables. Ah, this slot was for the cables. Okay, I get it. It was meant this way. inside. Since we didn't disconnect the battery, we don't have to reset the protection stick anymore. That's the other side. Okay. Yeah, it looks better. The screen looks a tiny bit better. It looks cleaner. Let's put this back on. Up. This is not held together very well. Cables, you go here. This goes there. Okay, now it is held together correctly. This goes up. Come on, this goes in here. It should be held together here. So now if I switch on, it should work. And it works. Finally. Loading. And now I have to wait 4 hours for the SD card to load. I'm missing right now. Let me just restart OBS for this thing to be working again. And OBS should be running again. Sorry for this interruption. I don't know what caused it. No, I don't. Now it's running. I hope that was not too long. And now we just need to connect everything back together. And this goes here. This goes here. The stamina button to be at the right place. Stamina button. Is there? No, it's centered. It seems to be. No, it seems to be symmetrical. Up. Up. The screws. We have these screws. We have here the middle, which needs the long screwdriver. This is the middle. And we have the corner parts. One, two, there should be four. There should be four, but I only have 3 rubber parts. Ah, yeah, that's weird. Yeah, this design is a bit weird, but at least 3 makes it not tilt too much. 1, 2, 3. Oh, it is still on. It is recording. Sorry, up. It's recording. Does this microphone work? Here. Yeah, this microphone works. And yeah, this is done. See, complete, closed, and it is now with a lithium polymer battery. So although it took longer as expected, I can now charge it with mini USB. Yeah, I can now charge it with mini USB, included charging battery. With that, the project is finished for today. So, and it's time for me also to end the day. So enjoy the rest of your day. And oh, this is weird. When I plug the USB in, it okay, now I get it. Why? Yeah. When I plug it in, it switches on the interface. But is it only? Yeah, this is weird. And when I plug it in into USB computer, it makes this on, and then it asks me if I want to connect as a audio device, which I use very often for my streams. If I just connect here, no, it still boots. And it does ask, but I don't care. It is charging. So It's sad that I don't see the LEDs. Can I see them through here? No, I don't see the status LEDs. I know it is charging though, so I just leave it for some time and this is done. So let's keep this charging and yeah, the stream is ended for today. So enjoy.